Please, maybe in the first and second row. Salvatore, prima fila. Bisogna cogliere l'occasione. Bravo. Siete più bravi e più obbedienti degli studenti. Gli studenti sono sempre là in fondo. Io dico sempre che c'è l'allergia alla prima fila. Mi ha mandato, sì, ho capito, perché insomma ha fatto una notte insomma. Lui per pagordi la notte. E poi lo dico sempre. Okay, good afternoon again. Last effort for this 2 days marathon, and I had the honor and the pleasure to introduce 3 companies before the coffee break, and now I continue to be honored and very pleased to introduce 3 colleagues, okay, because I come from university, and we want to close this session with some remarks from university and to understand what university does in terms of research, in terms of collaboration with companies, especially concerning the topics of application of laser in the e-mobility field. So we are going to meet Erika from the University of Bologna, Leonardo from the Polytechnic of Milan, and Sophie from the Technical University of Munich. Okay, so I hope you will for sure enjoy their speeches. So Erika, please, Erika Liverani from the University of Bologna. She is a direct colleague of mine, and we work in the same group under the guidance of Professor Fortunato. And please, Erika.
Thank you, Alessandro, for your presentation, and good afternoon to everyone. It's an honor for me to be here today and present our research group and our research activities. So manufacturing group in Bologna is larger than you see here, but of course we are divided in subgroups in order to respond to the current manufacturing issues in a higher specialization way. And so today I will present you the laser group. Laser group in Bologna is coordinated by Alessandro Fortunato, that you have already known, of course, and Luca Tomesani, Professor Luca Tomesani, who is the head of the entire manufacturing group. And so with them work fair number of people, from long-time researcher to young PhD student, and each of us has typically a main research topic, or we are specialized in few laser processes. Of course, we are a manufacturing group, so we need equipment. And here you can see a list of laser sources and laser systems that we have in our laboratory. And some of that equipment are owned by us, others are for rent or for lease, thanks to the collaboration with some of the most important laser sources suppliers. And so we have the possibilities to test different laser systems. As you can see here, now in our lab, we have different continuous wave laser sources, from diode laser to neodymium YAG laser, and of course, several fiber lasers with different powers. And now we have also a blue laser in our lab, and we are studying and we are using that new source for different applications. Of course, we have a QC view laser and different pulse laser, short pulse, ultra short pulse, and long pulse lasers. And then we have the possibility to use all that laser sources with different focusing heads and scan systems. We have different handling system, and at the end of the list, you can see that we have the possibility also to study additive manufacturing processes, because we have a laser powder bed machine in our lab, and we have the possibility also to use a direct energy deposition system. In relation to the topic of this workshop, Laser Group exploits its knowledge, the knowledge acquired in laser welding, laser cutting, and 3D printing in order to develop that process for e-mobility sector and e-mobility application. So now we are actively involved in several processes, as you can see here, and of course we will talk about that. I will talk about that in my speech. So let's talk about our activities, and I would like to highlight the dual nature of our work, because we carry out applied research activities for meet industrial needs, and we carry out fundamental research activities because we are researchers and we would like to improve our knowledge. We would like to write scientific papers, of course. So let's talk about applied research activities, and I would like to start from laser welding. We are involved in different laser welding applications, and so here you can see some examples: hairpin welding, welding of electrodes, busbar, and of course battery case. And I would like to show you and explain which is our approach to this activity. So we are a university, and so we usually start from laboratory experiments. So we start from a simple sample in order to investigate whole possibility of the results that we can obtain with our equipment. And so we try to optimize the process in a laboratory condition at the beginning. So real simple geometry and real simple setup. And we would like to do that testing different laser systems. So we would like to find feasibility windows for different laser sources, for example, or a system, because we usually find a solution with different systems, and this is our principal aim. And when it's possible, we try to optimize a process, an application, using, of course, different approach, and when it's possible, also different process configuration. Here we have an example. We are studying welding for battery case, and we are trying to do that with or without filler wire. And we would like to do that for solve some manufacturing issues. For example, in that case, we would like to control crack, we would like to control misalignment, we would like to understand the effect of heat input in the final results. So in this first step of our work, our aim is to find different solutions, and we would like to correlate the results with the system that we have used. Then we start to repeat our experiments on real component and real geometries. And usually we do that in our labs. So we always stay in a simple condition at this phase. But our approach is to try to scale up our knowledge, so from simple sample to real geometry, and the aim is to validate our results. And of course, we have some help from some methodology, some instrument, and as you can see here, we use design of experiment method, and in the last few years, thanks to the works of a colleague of mine, we are trying to use machine learning concepts in order to understand the effect of different process parameters or laser systems, for example. And at the end of these two steps, what we can do? We have tested different laser sources, different process configuration, different, for example, laser head, and when it's possible and when it's useful, we have tried to use complementary equipments, for example, monitoring systems. And so we can help company to decide which is the best configuration for their specific application. So we can help them during the design of their production line. Of course, we can help them only from a manufacturing point of view. And in that phase, usually we can ask the help of Nextema that we have already known today. And Professor Tomesani taught you the work. And of course, we are a university, so we can offer staff training in order to give to the company the expertise and the knowledge of the process that they would like to improve. But now let's talk about our fundamental research activities. And we can start from laser welding activity. And with this topic, now we have three main fundamental research activities. The first of these activities is related to the study of the interaction between different laser sources with this high reflective materials. So we are talking about aluminum alloys and copper alloys today. So we are studying this kind of interaction. And, you know, we have the possibility to use very different laser powers, laser system from different suppliers, and so we have the possibility to compare our result by changing power emission source, so from pulsed laser to continuous wave laser. We have the possibility to test laser sources with different wavelengths. So now we have a blue laser, so we compare the results that we can obtain with this kind of wavelength with our previous results with near infrared laser. And we have done a lot of work also in laser motion comparison, so from linear motion to wobbling, for example. Our second activity is a very recent activity, but I think it's really interesting for us and for industry, so we would like to study. And of course, the topic is the monitoring of the process towards zero defect components. And what can we do now? Now we are in a really easy step of our work, so we are studying, and so we can acquire raw data, we can try to analyze the data, and we would like to correlate that data with the specific defect. So we are using a commercial system, and now we can do nothing more than you have already seen in that 2 days, but we are studying and we are trying to collecting data. And we would like to do that because, as I told you previously, we are trying to feed our machine learning algorithm, and we would like to do that in order to detect defects, so from a research point of view. And of course, we have also a long time objective, and we are really far from there, but we would like to do it. And so the concept is to reproduce our process with digital twin concept, and we would like to predict that defects. Oh, sorry. Our third activity is a junction between our knowledge, because some of us study additive manufacturing processes and some other is really specialized in laser welding. And so we are trying to use our knowledge in order to understand the effect of this hybrid process. And we are studying now laser welding between traditional hot rolled component and additive manufacturing component. And why we do that? Because studying additive manufacturing processes, we think that it's possible to optimize components also in e-mobility sector, and we think that we can increase the functionality of these components. But we would like to understand the behavior of these components with different mechanical properties in post-processing conditions. So in that specific case, we would like to understand the quality of welding from these two different components. And so we are studying and we are trying to optimize process parameters, post-process parameters, and we are studying the mechanical properties of that hybrid junction. Then I would like to briefly talk about high-speed cutting of anode and cathode. We have done a lot of work in the past, and we are starting again to work in this topic. Unfortunately, I can show you recent results. So here you have some state of the art for us, but the idea is the same. The difference is the hardware that now we have the possibility to use. So we would like to test and use this new generation scan system, and with using them we would like to understand the quality of our cutting, also change laser sources. So we are carrying out a very big experimental campaign in order to define advantage and disadvantage of using different laser system. And of course, with applied research activities, we try also to carry out fundamental research activities, and so for each of that configuration, we try to go in depth and analyze the quality of the cutting, the profile of the cutting, and of course the edge of the cutting in order to correlate process parameters, laser systems, and quality, cutting quality. At the end of my presentation, I would like to talk and say a few words about our activity with additive manufacturing, because we are carrying on several projects on that topic, both from industry point of view and fundamental research activity. And now we have the capability in our group to redesign components for additive manufacturing, also for EV components. And we can do that because, of course, we have commercial software and we can use it, but also because we have the knowledge of the process, because I told to you that we have a machine, so we know very well manufacturing issues of additive manufacturing, and so we can use our knowledge in order to really increase the functionality of components. And at the same time, we are trying to optimize process parameters for complex materials as copper alloys, for example, for conductive components, pure iron and ferrosilicon alloy with different silicon percentage. For new generation rotor, we have a regional project on that topic. And of course, aluminum alloys. So I would like to conclude my presentation, show to you our very recent website. We have this website from yesterday evening, but if you are interested in know something more about our work, you can find some information in this website. And of course, I would like to thank EPG, Optoprint, and Presitech for the agreement and the collaboration with us, because thanks to this company, we have the possibility to use very state-of-the-art laser systems. And of course, we would like to thank our current industrial partners. Thank you.
Good. Thank you, Erika. Very nice. If some of you have some questions, comments, or curiosities, very quickly, because we are running out of time. So anyway, very brief comment from my side, and it is really valuable. Let's say the support of our partners. I think that also my colleagues from Milan and from Munich will agree with me that without equipment, we wouldn't do anything. No, I'm joking, but of course, we do basic research, but we do a lot of applied research. So the laser has a great defect that if you do not try, okay, you can be the biggest and the largest connoisseur or expert of the theory, but if you do not put it in practice, it's very difficult to be effective, especially towards the industrial needs. So I would like to thank again all the partners, not only the partners of the University of Bologna, but also all the partners that help us, universities, so to carry on our research. Okay.
Thank you.
Okay. Now is the turn of Polytechnic of Milan. We have Leonardo Caprio. Please, Leonardo.
Okay, I hope you can all hear me. Okay. It's a pleasure to be here with you today to this big event. I know that it's being followed online quite a bit, and I hope that we can all find new ideas and new stimuli on how to go ahead together on these new topics. And my presentation to you today is about the application-driven research for the development of the different laser-based manufacturing processes. Okay. Okay, so just a brief introduction on who we are. Okay, so we're the laser manufacturing research group within the Polytechnic of Milan. We are a very big university, as you know, in Italy. So we have students from different backgrounds working with ourselves, so from engineering, architecture, and design. CTEC was founded, so our research group was founded in the early 2000s when we had the first fiber lasers in Lecco, and we moved to Bovisa in Milan, where there's the current site of the Polytechnico around in 2007. And since then, we've been developing a different number of laser-based manufacturing equipment. In 2021, we've been creating a cell dedicated to the study and the development of the LaserEMobility processes. Okay, and I will be talking a bit more about the different cells in the next few slides. So just a brief word about the team. There's one full professor, one associate professor, and there's me and another assistant professor, which direct the work of around 30 people within the laboratory. So you will usually not find me with a suit in the lab, okay, working with my work hardware. And what you can see here is the view of the of our lab. So with the different wire deposition cells, okay, and the laser-based manufacturing cells for the different applications which we develop together with companies. And we range from laser cutting to laser micromachining, robotic laser welding, and all the other laser-based manufacturing processes that you might want to introduce into the chain for the e-mobility processes. And most recently, as I was saying, we have the LaserEMobility cells, which is equipped with an infrared fiber laser and a green wave fiber laser. Okay, so how do we conduct our research activities? Our research activities range from what we call fundamental research, so the understanding of the process basics, okay? So here we're working at low technology readiness level, okay? And we tend to do this together with other institutions such as Bologna or TUM, and also with other research institutes around the world. Then we also work across through funded projects and projects with private companies where we move to higher levels of technology readiness level. And so we move from, let's say, publishing our research that we conduct on the fundamental research to producing patents with our industrial partners on the different applications that I will be talking to you about. And just to give you an idea, we work throughout the whole of the, let's say, manufacturing chain. So we start with the laser equipment manufacturers. Okay, so you can see the logos reported up here of our collaborators in this field, to the application developers and the machine tool manufacturers. Okay, so we follow them into putting into action the laser-based equipment that is being studied in the lab, to the actual end users of these systems. So we actually go and see how these systems are put into place and how they actually perform throughout the manufacturing chain. And just to have a closer look at the different systems that we have within CTEC, okay, we have a laser powder bed fusion system laboratory. So we started with some prototypal systems, starting to print pure copper a few years ago, and moving to the development of dedicated systems such as the high temperature laser powder bed fusion system that you can see here, and multi-material laser powder bed fusion concepts. So we test out innovative concepts, okay, at very low technology readiness level, and then we move also to industrial machine, where we integrate beam shaping technologies in order to optimize the process parameters during the laser powder bed fusion process, and also allows us to advance in the deposition of new materials and new alloys. And once again, okay, here we try to work towards the alloys and the materials which are of interest for the mobility applications, so aluminum alloys, pure copper, and iron silicon alloys. Here you see also some of the robotized cells that we've been developing in the last few years in collaboration with our partners. We have laser systems which have multi-mode fiber lasers equipped with wobble heads and powder hopper. What you can see here is also a high-speed video of the laser wobbling process, okay, during while we make a lap joint weld. And also we've been developing sensor systems that are applied to our components, okay? So we have no seam, so in this case what you can see is what happens when we don't apply the seam tracking to the welding of this component. And on the other hand, in this case study, we are actively employing our seam tracking system, okay, to correct the direction of our robot in real time. Okay, so we've been developing this type of application together with BLM Group. And on the other side here we have the directed energy deposition, and this can be very useful for the prototyping of components. Once again, also, well, this is for, let's say, the old generation engines, but might be applied also to new concepts of materials. And what is, we're also, okay, let's move, okay. So, and also now, the new systems that we've been working on and developing are the laser micromachining laboratory, the LaserEMobility systems. As I said, we have different pulse wave laser sources and remote scanner heads that are being put into process. We have equipment from relays, which allows us also to add monitoring equipment, and I will be talking to you a bit more about those aspects towards the end of the presentation. And we have, so the advantage of these type of systems, as also Bologna is doing, and probably also TUM, is that they're reconfigurable system, okay, so we can develop the application based on the needs of the customer, and I will be showing you some applications that we've been seeing together. And most recently, we've been introducing a laser-induced forward transfer system, okay, so this is a very particular technology which allows to do a multi-material deposition in the nanometer range, and so it's an additive manufacturing material that can also be maybe applied for the electronic sector, and this system is currently under development in the laboratory. Okay, and just to not forget what we do, okay, so we start from, let's say, from teaching fundamental courses throughout mechanical engineering, okay, degree, where we start talking about laser systems, okay, and how they can be applied in the industrial, for the industrial uses, okay, and these type of courses we also hold them also for second level masters, and we create also dedicated training for the private sector on specific themes. Another interesting aspect that what we are trying to do is trying to get the students to come as much as possible in the laboratory and get their hands dirty. This is obviously something which requires a lot of energy on our side to get the people in the lab and to actually prototype and conduct some activities, let's say hands-on activities. But it's also, let's say, very rewarding because our students also get to actually start seeing which are the different laser-based manufacturing processes within the different applications. Okay, so what you can see here is the case study of where in this year's Advanced Manufacturing Processes Laboratory work, where we've been developing a drone which has produced with laser-based processes, and we've also started prototyping small lithium-ion battery packs. And just a very quick touch to what is ITEM and the Laser Safety School, which so for the development and the study of laser safety related issues, we've also been creating a partnership with different universities and in different industrial companies within the Italian sector, okay, so we can also be a reference for you also on these type of topics, also thanks to the collaboration with the University of Pavia. So it's upcoming. So moving on to the applications that we can see in our laboratory related to the e-mobility sector. I won't be going too much in details with regards to the industrial applications. We've already been seeing quite a lot from some of our partners during these days, okay, but we range from hairpin stripping to carbon fiber cutting, the electrode cutting processes, battery pack welding, and hairpin welding, okay? And we're also now working on the additive manufacturing of statoric components. And having just a look at what are the, let's say, the two main laser-based processes in this stator manufacturing, okay, this collaboration with EM Automation Atop, Okay, so we've been working on how to benchmark the hairpin welding process. Okay, so how to define which are the actual, let's say, most important features that must be taken into account in terms of qualification procedures, both for the welding components and also for the hairpin, for the stripped hairpins. Okay, so define which are the correct approaches in terms of material qualification, and in order to identify which are the quality metrics that make the process reliable. Let's see if it goes ahead, sorry. And so finally, I would like to come to the case study from our laboratory. Okay, so just a couple of years ago, a crazy Master of Science student came to us asking us to manufacture a battery pack. Okay, at the time we didn't know much about lithium-ion cells. Okay, but we had to learn quite quickly in the process. Okay, so we started from the design of the battery pack. So we were talking about a 50 kilowatt battery pack with 126 volts. Okay, so it's a battery pack composed by 750 cells, which each require a welding, a dedicated welding process. And one of the most critical components that we identified was the manufacturing of the Busbar, which due to process requirement, we decided to manufacture in a mixed way between copper and helium. In this way, the joining of the Busbar was conducted with the helium side on the lithium-ion cells, and I won't be talking much about this in detail during this presentation, but what I'll be focusing on is rather the joint between the copper and the helium sheet, okay, that was used, and also how we started to, let's say, study more in detail how we can introduce process monitoring to identify the defect formation and some of the critical aspects that we've been seeing in these days. And so the very nice thing, okay, so we didn't win the competition, Bologna did last year, but we still, there were technical issues in the final race with the electronics of the component. The battery pack was actually working quite well since we achieved the top speed of the competition and the maximum acceleration as well. And so here you can see the manufactured battery pack at the end of it. And this is our e-mobility cell with the relay scan head and a light 1 kilowatt fiber laser. And we have a spectroscope and some off-axis photodiodes that we introduced. Okay, and so the first part of the study of the process was related to the process parameter optimization, so identifying stable process parameters which guaranteed a good contacting between the two materials. And also, we then started to use these sensors that we introduced in an off-axis configuration, but might be implemented, as you know, in a coaxial configuration in order to identify the formation of different defects, okay? So starting from the reference welding condition, we simulated defects such as a gap of 0.1 millimeters, or the fact of having the workpiece defocused by 3 millimeters or 6 millimeters. And in designing the sensors, okay, so this is something we often take care of, is the choice of the wavelength bands that we want to observe when we start observing the process. Okay, so in this case, since it was an exploratory work, we started with a spectroscope and then 3 different photodiodes off-axis and 1 coaxial photodiode within the laser source that is directly available. And so what we started to do, okay, started viewing these signals, okay, so how they change from the reference condition, which is shown in blue, towards the cases where we have gap formation and defocusing of the component, okay. So in the case we've placed badly our component, and you can see this is the effect on one of the sensors, and this is the case, what happens on the spectroscope. And then what we do, okay, and this is, I don't want to make a mystery about this, okay, so it's pretty clear what we do without very, let's say, complex words or mysterious things about what we're doing. Okay, we take our signals, we start finding some statistical indicators which are significant, okay, so we call this feature engineering, okay. So identify, in this case, we used very simple indicators. In other cases, maybe we need to think more in detail on what we can use, but we use mean, variance, peak-to-peak values, and we use these as an input to our machine learning algorithms, okay? So what you can see, okay, without going once again onto complex aspects, okay, we can see that these different indicators for the different weld conditions, okay, they come out quite nicely in our graphs, okay? So we can start seeing already by eye how they allow us to differentiate between the different conditions. And this is the case of one of our sensors, okay? And we can start evaluating our machine learning algorithm using a confusion matrix, okay? And if we choose the right sensor and we tune our machine learning algorithm, okay, what we can see is that we can improve the identification percentage of our algorithms, okay? And so just on a final note of this type of application, of the future applications also. Let's see if it goes ahead. Okay. Okay, so in terms of the future researches in CTEC, okay, so what we're still going to work on is the study of advanced process diagnostics and control. Okay, so here we can see how we used coaxial cameras and off-axis cameras to observe the process and identify the melt pool, which is a very important quality metric. And we use this for different processes. And we can also apply this to biodegradable electrodes, okay? So we're studying additive manufacturing of these new materials. And the next big things that are upcoming are large size additive manufacturing and the laser healing of carbon fiber materials, okay? So if you have any question, I'll be glad to answer. And thank you for your time.
Thank you, Leonardo. If you have any questions, comments, curiosities. Also at home, no one. As you can see, we are, let's say, colleagues and in a certain way competitors because we deal with very similar aspects. But anyway, we are trying to make let's say, a critical mass together because if we are alone, if you do our research alone, we can do less than what we can do together. So together with Gökhan and our colleagues, we are trying to do something in common to gather our potential together and be much more effective together than we are alone. So we hope you appreciate our efforts, of course. Okay, no questions?
Okay.
Good, Leonardo, thank you.
It's either I'm extremely clear or no one understood anything, but probably the second option.
Okay, thank you. Okay. Tries to be very effective in keeping the pace of this very quickly growing technology. So this is a demonstration that you can trust our work because if you noticed, many of our groups are composed of non-permanent people. So there are very few permanent professors and researchers, and many others are PhDs and scholarship owners and the research fellows. So this means that our job, our activity is really driven by our passion. So I hope we demonstrated it in this last part of our workshop. Thank you again. So now it's time to switch to the last, let's say, session. This is the roundtable discussion. Gökhan, we come here, if I'm not wrong. Okay.
Okay. First of all, thank you to those who have managed to remain until this hour. So we have some time left for a roundtable discussion. We don't have a roundtable. So the idea is that if you want to participate, maybe you can come forward. Otherwise, we can help us with the microphone. So we're ending a 2-day discussion. This was a first attempt for all of us trying to get a community together. We started in an international way. And we had some really vibrant discussions regarding some key applications. We started from the key applications, apparently at least. So it was mostly related to batteries and electric motors. We were speaking to each other because you have seen us moving around, speaking to you, asking questions to ourselves. So maybe we can speak today at this point before we go away, if we have some energy left to us. What haven't we said? Let's also have an idea about what we haven't said today, because lasers are highly flexible. We have temporal, spatial, and wavelength domain flexibility. And we have spoken mostly about metals, right? So we had some brainstorming ideas, but let's start to bounce the ball towards the things that we didn't say so much. So we're worried about batteries. We're worried about ranges. What about other weight-saving options? So let's speak about the car body, how we can do other things in terms of welding, cutting, trimming, maybe also composite materials that we didn't speak about. So let's start from this idea, what we haven't done, so that you can tell us what we should do next year. Maybe change the topics. Any ideas? Anybody who wants to share? I think you want to say something. Yes, thank you very much for breaking the ice.
We haven't been speaking about how we integrate the battery modules or the packages into the car body itself, because there's a lot of weight saving possible. We're talking about the single battery, we combine the battery, and then we stop. In this workshop, we stopped about talking where we put them at the end.
I didn't get the last part. We have a lot of...
We have been talking about how we combine with the bus bars, how we combine the batteries, how we make the modules, but we have not been talking about how we integrate the modules into the body itself, because there's still a high potential of weight saving.
For instance, in an electric car, we will have more welding, right? A lot more welding than the conventional one.
I hope so.
I think you would be happy with some more welding, so some more millions of data coming in, flowing in. So, Johannes, help us out.
I think what is also maybe an important topic is that at the moment we have three main different cell formats, which is the round cell, the prismatic cell, and the pouch cell. But when I saw the schemes of the motorcycle, for example, today in the morning, maybe it's not the best idea to try to fit a battery module made out of round cells into that motorcycle, but more to have a flexible module made from different cells with different formats, or attached perfectly to the motorcycle. Because I thought you also need to keep the balance of the motorcycle, to have the weight in the right place, and to flexibilize the type of batteries or the format of batteries might be an option, and this will also require flexible production processes and flexible welding processes. So this is maybe another aspect to mention here.
Anybody wants to add? We have Mr. Mazzotti here. Giovanni would like to add.
Just to brainstorm, I mean, I wanted to share with you an experience we have done with battery cooling systems with an important German car manufacturer that I cannot disclose. But we have been involved in, let's say, 3D cutting of the pipes that let's say, bring the cooling liquid around the batteries. So we were dealing with plastic, so obviously CO2 was in his domain. So we haven't been talking at all about the cooling requirements for batteries. I don't know if this is something that is already, let's say, fully investigated, or there is still some room for working on it. Thank you.
So I think the observation here is that we rediscovered the established processes applied to new products. So a 3D cutting operation with a CO2 laser, now it becomes important once again because we're speaking about polymeric materials, right? So it reminds me, I'm not that old, but there used to be that day we spoke about CO2 and fiber lasers for cutting metals, and then we said we won't go back to CO2s, but it's true that we have a lot of polymer processing now, so we will need CO2 lasers or infrared lasers more.
It's not rocket science, but it's still, I mean, maybe the laser process is still to be tuned or whatever. So just something to throw on the table.
Yep.
It looks like no laser is getting old. Even the oldest ones are still very, very, very young. And new opportunities arise every day. So nothing is to be discarded, but we have to, let's say, to reinvent how to use also the, let's say, most assessed technologies. We started with a CO2 laser, and it's the former love.
So speaking about polymer processing, because I'm looking at the room and I see faces that can give other answers for polymer processing, other wavelengths, maybe, which can be also fiber delivered. Do we want to speak about also these new colors and so on that can also contribute to the processing? So there are also new laser sources that we haven't explored so much, and other active media, and so we spoke about those things also yesterday. Then we have also the need for new optics for those, or we need more of those optics, so that polymer processing will become once again very important, not only for cutting, but welding as well. So we spoke about hybrid welding operations, right? So polymer to metal, polymer to ceramic. You need to bond things, and absorptivity is something managed by longer wavelengths in that case. So those things still require maybe more attention, because there is not a single laser for all operations, evidently. So that's another point for future ideas. Anything coming from the audience? Salvatore wants to add. Thank you.
I have a question for the university guys. So it's just brainstorming, as we were saying. According to you, do you have all the open questions and needs clarified by the end users? Or do you still think that there is the need for them to better clarify all the needs of this new technology?
This time, let's start from that side.
Okay, it's not easy to have, let's say, the right questions at the right time, because, industry needs everything for yesterday, okay? They ask for you today, but they expect it was ready for yesterday. Okay, this is a common joke we have together, of course. But I think that the most important thing is to have a continuous relationship, because the world of e-mobility manufacturing is growing very fastly, so nothing is completely assessed immediately, and nothing will be completely assessed tomorrow, but it is a continuous cycle. So what we try, for example, at least from our side in Bologna, we try to have a constant talk with our partners, with industries, we ask for some of our colleagues today told give me samples to make trials, to understand what we can do, what we cannot do, and this is our approach. If there is one thing we ask to end users or to companies that come to us to ask for support, we ask to be as clear as possible, to explain the needs as good as possible, and we ask them to understand that there are some constraints that have to come from their side. Very often, companies think that we can do all, we can suggest all the constraints of the process, but it is not true, because there are some very specific constraints related to, I don't know, productivity, to defect management, that we are not able to manage directly. So constant talk and collaboration.
Just one thing, do you think is it an open discussion and clear? I mean, are they willing to disclose information that you're looking for, or they?
We
because
sign
I mean, time
NDAs every day. So. I think so. And, of course, we are ready to listen to as many details as we can get. Of course, sometimes there are non-disclosures, that there are disclosures that cannot be revealed, but usually we manage to have a good talk.
Thank you.
I think I would totally agree with Alessandro. For us, it's the same. We try to do brainstorming with industry partners as often as possible, and often it helps when we already come with an idea to start the whole thing. But then there is also, to give an example, where maybe the potential of academia stops. We've been looking into electrode cutting lately a lot, and one of the biggest problems is particles or quality defects, which might, in your battery cell, in the end damage the separator layer and lead to a short circuit and maybe a burning battery in the worst case. But that maybe doesn't happen like for every second cell, but that happens for, I don't know, one cell out of 100,000. We all remember the accident with the Samsung cell, and it was I think a really bad image problem for them afterwards, and it was one or two cells of a lot of cells. So I think in the end, for example, for quality aspects, industry needs to give us clear directions, what is required, how big can particles be on an electrode, how big can the burr or the heat affected zone in an electrode layer be, because we just can't give a clear direction in terms of that.
My first and simplest answer would be no, we don't know exactly where we can help the industries. We still need to study a lot. What we have is, you see, 3 universities with applied research capabilities. We know how to resolve issues, we have the methods, and we have a good understanding of the photonic tool. But we still need to, so this is a slightly different case. You have basic research, it used to take 10 years to come to an application. Then it used to take 5 years to come to the application. Then it took 2 years. Today, we're trying to catch up with the industry in a subject that requires solutions for yesterday. Because we have a gap, the technological gap needs to be closed, and we need a very effective communication. It's very difficult. I think this is one of the outcomes of a workshop of this kind. We try to put together people, and we try to initiate a discussion. But we definitely need to talk more together between each other. And this is not only industry and academia, we need to speak between ourselves. And we were also speaking about the fact that it's a multidisciplinary field. We need to speak maybe to the chemistry people. We need to speak to physics people, material scientists. There's a lot of things that need to be done. We are in the phase of communicating, understanding these issues. The difference is that the time is very short. It's very short if it's not already, so we're trying to gain some ground over that. The point is the communication has become very important, and this is one of the things that we try to convey as a message. As Alessandro says, as Johannes always also does, we sign agreements so that we do research for companies, which we like very much, because I think we all agree that we do things that we want to apply. But in order to have a bigger pace, we need to increase the amount of people joining in the discussion, releasing information, speaking about the requirements. So lasers are flexible. We know that they can cut, they can texture. We have optics that they can measure things. One of the other things that has come out, and people underline this very much, is the need for human resources. So it's true that we do research. We do research, we resolve a problem, but then actually the biggest output is the human resources that we make. And I think all of you would agree that today engineers are demanded so much in all of Europe. In Italy, at least, we know that we can't keep them in the university for very long. They are literally stripped out of the classrooms because industry needs them. So we need to train more and more people also for the communication purposes, so that when we go to a company, we can find someone to whom which we can speak to, so that we can also explain how we can operate, what we can do, and so on. So it's a good time, in my opinion, to do this, in my opinion, to start speaking about these more in detail. And the hope and the work that we will do for the next year at least is to increase technical details, the amount of applications, so that everybody goes home maybe with a bit more confusion in their heads, but at least they can think about what they can do.
So I agree with that, and so I think that this workshop is very useful for this kind of starting this path, but I encourage you to go even faster, because time is not there. So I guess, so the PhD idea for me is a very interesting one, and I think you should push companies, private companies, to go after that. And also, I guess that at a European level, you should try to propose something, a path that can be followed by other universities and together with private companies, in order not to waste time and to address the actual needs that industry needs to be solved quickly. Thank you.
I agree with that, and actually, I don't want to repeat myself too much, but workshops are nice. It's a good opportunity to sit down and see each other, and this time we really wanted to be face-to-face, so because we came out after a 2-year pandemic, and hopefully this is the end of it, and hopefully we won't have any more disasters, hopefully. But we need tangible results. That's what we are looking for. So PhD is a tool. We can try to do it. Of course, this is a proposal to start off with. We need also more key players coming down here and making demands, requests, pulling us together. We need to do these things, and European projects are also a tool to do that. But now maybe this is too much of a detail, but speaking about the time frame of everything, I think we need to move quicker than writing proposals, getting the grants, and maybe moving towards the industry. But of course, they have a lot of added capability, so that we do research for the upcoming years, maybe not an immediate result. I don't know if you have anything to add.
Not really, but one thing I want to say is that I'm, at least from my side, I'm really satisfied with this experience, this 2 days experience, because it is the demonstration that if we put together all the actors in this movie, the movie goes on in the right way, because we have seen car manufacturers, we have seen laser producers, we have seen optics producers, monitoring system producers, and integrators. I think basically everyone's speaking the same language, a language devoted to find solutions quickly, effectively. That is not, there are 3 adverbs not so easy to put together, because it's not easy, and I hope that we will be able to promote events like this in the future more often, and to be even more focused on needs, markets, and so on.
I think these are the general remarks. I see that the faces are all tired, and the number is decreasing. So
Yes.
maybe let's wrap up with a short closure. And I'm asking the people in charge of the presentation. We just wanted to show you some numbers before we say goodbye, okay? If we can.
Just to tell you how good we have been.
Of course, if we can have the presentation, I don't know if anybody is able to do that.
Some tips, suggestion, or whatever. So I had the same thought of you before. That's the emergency. Now it's a lack of the manpower that speak our language, photonic language. So suggestion for the next, as soon as possible, try to make this fashion. So how we can collect people in the photonic world that then goes to the company, the end users, the integrator, and speak our same language, photonics language, so we can maybe have this open discussion, understanding better the value and the need they have. So first suggestion, how we can make this fashion and appealing for other people to join the photonic world and understand it better. And the second thought I had is about this needs to integrate more wavelengths, more process in one factory, one machine. So at the end, it looks like that the process of e-mobility will be sum of a lot of different processes that can be achieved with different wavelength, different kind of systems. And so I guess that's we also have to drive our research, our investigation in how we can present to the end customer an all-in-one solution that is not just, this is an infrared solution for this metal, this is another solution for composite, but is from foil, from zero raw material to the battery. This is the 3, 4, 5 steps. You can do it in 3, 4, 5 systems, and all together can fit in one building. That is also an idea to give more a simplified version of the machine, because we are used to go to the integrator or to end user and say, I want a machine that is plug and play. it's not possible at the moment. So maybe we can try to make it more than this. That is my 2 cents of the discussion. Thank you.
Thank you, Luca.
Thank you, Luca. It's true that there's a fashion side of what we need to do, but I'm not blonde and I'm not tall, so the idea is that. Thank you very much. As the number of people decreases, it becomes more of a friendly discussion. Okay, thank you very much. So, thank you all for joining. So let's see some numbers before we leave each other, and hopefully this will be good enough to say that we want to do it once again. So we had 9 sponsors, 5 sessions, and 24 presentations, and we're ending it now. We had a remarkable number of registered participants, thanks to the hybrid and English format that we wanted to adopt. So we reached above 500 participants today in the morning, and this is something that requires probably us to reflect to a bit more for the upcoming events that we will organize. We actually reached more than 20 countries all over the world, and you can see some of the names because after a certain while it was difficult to also arrange them, geolocate them and so on. But from this point of view also, the workshop has been quite a success, and it has been able to reach a really broad audience. Just to remind us, we met each other going through these workshop sessions. We had the exhibition area for those who weren't able to see us online, which was also a quite good moment for us to exchange ideas, see some of the actual hardware and so on. The brainstorming session was also quite a fun event, and we will get back to this and probably write a document out of it so that we can share with the people discussing the ideas. Thanks once again to our sponsors. Definitely, without their contribution, this wouldn't have been an event. And thanks to their contribution, we were able to do a lot of the things that we achieved today. I mean, the logistics, all the offered breaks and so on. So thank you very much once again for your contribution and coming down to speak with us as well. Of course, thanks to our partners supporting us, Pirex, Applicazioni Laser, and Epic, who contributed to the publicity, to the organization, and so on of this event, which we managed to go through these 2 days at the end of the pandemic, which wasn't very easy to organize. Once again, thanks to my colleagues, Bologna, Munich, and then here I am from Milano. And thanks to our also industry partners that are team members of LaserEMobility, and hopefully we will also engage with more of you. Last but not least, I think we agree that we can go on with this. So I think we can keep working in this community. We can try to expand the network. So the idea is that LaserEMobility will try to go between the LaserEMobility cities, at least in terms of academia. So next year you're all invited to Milan, okay? And next year we intend to have the workshop with the industrial participation and the conference with a more academic side to it, so that we can also see more technical details coming out from the universities. We're looking for doing this around in March, and the details will come up next. Maybe 24, Munich. Let's see how it goes, okay? So thank you very much for bearing with us these 2 days, and I really hope to see you again discussing more details, discussing more applications. Thank you all.